It's time for Security Now with Steve Gibson. We've all seen the article. Thomas Bechtel wrote an article about, well, basically asserting that the passphrase, "this is fun," is better than an 8-letter random password. Not so fast. Steve Gibson explains the problem next on Security Now.
Netcasts you love.
From people you trust.
This is Twit.
Audio bandwidth for Security Now is provided by Winamp for Android, the ultimate media player for your desktop and Android device, featuring wireless sync. Download it free at winamp.com/Android. Video bandwidth for Security Now is provided by Cachefly at CACHEFLY.com. This is Security Now with Steve Gibson, episode 297, recorded April 20th, 2011. Past sentences. Security Now is brought to you by Freshbooks, the easy online invoicing service that gets you paid quickly and makes you look more professional. Get started with a free package at freshbooks.com. And by Netflix. Watch thousands of TV episodes and movies streamed to your PC, Mac, or TV instantly. Plus, get DVDs by mail in about 1 business day. For your free 30-day trial, go to netflix.com/twit. It's time for Security Now, the show that covers your security online with the king of all of this, Mr. Steve Gibson of grc.com. Steve is the man who first discovered spyware, coined the term, wrote the first anti-spyware program, but he's been doing security for a lot longer than that. He's also the author of a great hard drive maintenance and recovery utility that's still #1, Spinrite. Hey, Steve.
I'm glad that we've dropped the man, the myth, the legend.
Well, you're that too.
Intro. I don't really miss it.
He blushes every time. I don't want to make you blush. But I really should say, first and foremost, one of my dearest old friends, and always a pleasure. We had you on Twitter a week and a half ago with Pornell and Dvorak, and
it's really fun.
It's just so great.
Yeah,
that us oldsters, because we're the same age, can still participate in technology.
Yeah, we're still getting to our computers.
Well, more than that, we have a context.
We may be sitting on balls, but we are in front of our keyboards.
You're not sitting on a ball, are you?
No, I'm not.
I am. No, I think I think what we bring to the table, though, is this memory and this history. Aaron Newcomb was doing Floss Weekly. He was in here, as you know, a minute ago, and we were talking about old computers and your first computer and stuff. And I think that there's a whole generation that grew up with super powerful computers and iPads and stuff, and they don't know the history of all of this.
Well, and you know, I see things on the net from people who are clearly newbies, which I know it's great. Everybody is at one point.
Yep.
We were once, but there certainly is something that you get from having seen a lot of things before, that where you say, okay, well, let's put this into context. And in fact, that sort of is a perfect segue into today's topic, because somehow through Twitter, and maybe you were the genesis of this, I started getting a lot of people asking me about a blog posting which actually is not even new. It was originally posted in, I think it was September of '07, by a guy in Denmark who's not really a security guy. He's sort of a new media guy. Actually, I think he's like in charge of new media for some fashion designing company.
Kidding. I should have dug deeper. I mean, I think I saw it on Hacker News. But,
anyway, the concept is he makes the assertion that 3-word sentences are like vastly stronger than anything else you can do for a password.
And memorable.
And so, and the advantage being, yes, that you know, like I like pudding or something, and so he makes the assertion that that's vastly stronger than like random gibberish passwords. And so I started getting everyone in Twitter saying, is this true? Does this work? Does this make sense? And what's compelling is that he is the graphical design of this page is very nice, and he unfortunately he's made a number of logical mistakes.
Oh shoot. I thought it was too good to be true.
Yeah, it is too good.
Oh, shoot.
But and then in his FAQ that he has, he also contradicts himself in a number of places. So, I mean, I wanted to give this our type of Security Now rigor and also sort of move the bar a little further in our discussion of passwords, which we haven't covered for like 5.5 years, because it turns out that was the original series of topics when we began Security Now with episode 2 or something, I think it was. So I think everyone's going to find it very interesting, and we're going to talk a lot about bits and password technology and binary stuff. Some interesting news. Some broke just an hour ago. I may have scooped you on one of these things, Leo.
Oh, good.
So we'll see.
I love this. Well, we always have you. I love this show. There's always something to learn. There's always something new. And I meant to send you an email about this, and I'm so glad that our listeners did. They're very proactive, because I really want to hear what's wrong with this.
Well, and before I forget, I want to mention that there are throughout this a number of URLs. And I was thinking, how am I going to share these with people? Well, first of all, I should mention that I recently grabbed the domain grc.sc, as in shortcut.
Oh.
So that I could do my own URL shortener and give it the kind of security features that we would like it to have.
Fantastic.
I haven't yet implemented that, but then I realized I had recently tweeted all of these things, and so even for old school people, I mean, I got excited when I saw that Jerry Pornell had a Twitter account, and I forgot to give him some feedback about that when I was on Twit with you guys a week and a half ago. Then I realized it's not really an account that he's tweeting on. Rather, it's some bot that takes topics from his blog or something. So it's some sort of an automated gizmo.
We've been working on getting him on Twitter.
Yeah. And anyway, so for the people who are not on Twitter, if you just go to twitter.com/sggrc, what that gives you is my feed, and all of my recent tweets will be there. So for example, I informed people several days ago that this was going to be our topic this week, because I finally thought, okay, this needs to be what I talk about to satisfy all the people who are asking me. So where we have strange URLs, I've already tweeted these things, so you can find them. You can just pick them up at twitter.com/sggrc.
That's a great idea. That's great. Thank you, Steve. So before we get to that, and of course we have security updates and a lot more to talk about as well. Steve,
some fun news, yes.
It's been busy, and people are saying in the chat room, is Steve going to cover the iOS tracking issue? Well, don't you know Steve by now? Of course he is.
Top of the list. You see it right in front of you there, Leo?
I do. So
iOS is and has been tracking us.
So I'm very curious about this as well. But before we talk about that, let me talk about Freshbooks.com. In this case, the cake is not a lie. Freshbooks will send you a birthday cake. Well, not necessarily. They'll have a drawing from among all their new users every week for a free birthday cake, whether your birthday is on that day or not. What is FreshBooks? Oh, FreshBooks is amazing. FreshBooks is an online invoicing service that is just superb for anybody who has to send out invoices, as I did for many years. FreshBooks, Amber MacArthur told me about this in 2004, and I and 2 million others have been using it since. It makes you love invoicing. I know that's hard to believe, but the advantage of FreshBooks is you do it all on the web. Now, of course, you upload your logo, so the invoice they send looks just like a professional, great-looking invoice. But there's some real advantages to using FreshBooks. For instance, automatic calculations of currency. I used to bill Canadians as well as Americans. They solved that problem. That was nice. Sales tax and GST and all that stuff also handled. If you're tracking hours, you can do it with their FreshBooks app on the iPhone or on the web, and then it will automatically take those hours and put them right into the invoice. This is very professional looking, and there's some features that you can only do electronically. Of course, many clients, I suppose, still require paper invoices. They'll do that too. You do it online. For an additional fee, they will print, stamp, and mail it, and it looks really pro. But many clients nowadays will accept email invoices, and that's when it really starts to sing, because there's a button on that email invoice that says pay it right now. and they can use a credit card or any of 14 different online payment services to pay. That's probably why, according to a user survey of FreshBooks users, they get paid on the average of 14 days faster, 2 weeks faster after they start using FreshBooks. If you are slow pay problems, well, you got a great automatic reminder service. You can even have automatic invoicing and collections if your client agrees with that. That's fantastic. It's just a great-looking, great service to use. And here's the best part, free for your first 3 clients. So if you're a small startup or you're just getting started in this business, it's absolutely free. Try it free. If your clients agree, you can do it for all of them for very affordable prices, but free for the first 3. Freshbooks.com, and yes, somebody who signs up in the next week will get a birthday cake. I love it. Freshbooks.com. Give it a try today. I give it the Leo seal of approval. I used it for many years. Very, very happy with it. So, yeah, this broke. This iOS thing just broke yesterday, I think.
Well, actually, it was blogged by one of the discoverers earlier today, today being the 20th, which is Wednesday of April. There's an O'Reilly conference going on in Santa Clara from yesterday, today, and tomorrow, April 14th through 19th through the 21st, the so-called Where 2.0 conference. And 2 guys, Pete Warden and Alistair Allen, are planning to announce today their discovery that our iPhone and 3G iPads, that is, those devices with cellular connectivity, so not, for example, the iPod Touch, nor the Wi-Fi only iPad, but those cellular connected devices from apparently starting with version 4 of iOS. So not prior to that, but starting with version 4, those devices are regularly recording the position of their location and syncing it with iTunes to build a large and growing composite file it's titled consolidated.db. And what they discovered was this file contains a wealth of information about the location of that device or devices over time, including the longitude and latitude and a time date stamp for that location. And Alistair also wrote, because he was the person who did this blog posting on O'Reilly's site that got picked up by the various news spools. He said, for example, in my own case, I discovered a list of hundreds of thousands of wireless access points that my iPhone has been in range of during the last year.
Wow.
So as far as they know, this is significant. I want to make sure we don't overblow this. As far as they know, this is not being shared with Apple. That is, they don't believe it's being transmitted to Apple, but it really does beg the question, what is this for? Why is this file being built? What purpose does it have? How is it accessible to the outside world? They raise the point that from a privacy standpoint, once it's known that it exists, and now everyone knows it exists, if anyone had access to it, then your location and whereabouts through time when you're traveling around with your iPhone, as most people do, or their iPad, as I do, is all there. For the Mac, they produce a free little bit of software, which you can get to from the link from their blog posting. And I imagine this will be, much in the news in the next day or two. And again, you can get the link. I have it as an O'Reilly shortened link, but I linked to it from my Twitter feed. So twitter.com/SGGRC. And you'll find my first note of this earlier this morning on April 20th. Their blog posting, Alistair's blog posting, has a link to the software. So I grabbed it and downloaded it. It was tiny, I think 132K or something, ran it, and immediately I'm looking, sure enough, at a map of the U.S. with a little concentration showing in Southern California, and I zoomed way in on that. It also has a timeline slider along the horizontal and a zoom scale on the vertical, and I zoomed in, and sure enough, I mean, it knows where I've been spending all my time. It was right there on the map. So they have asked Apple what's going on, and there's as yet been no reply, though I don't know what length of time Apple had to reply, and I'm sure we will, within a day or two, know much more about this. And apparently, there's even more stuff in this file that they will be talking about. For example, I only mentioned the longitude, latitude, and timestamp, but we also know that all Wi-Fi contact, we know from what Alistair wrote, all Wi-Fi contact is being logged in this too. So I wonder why, and we don't know.
Could be diagnostic.
Yeah, I mean, again, it's like, okay, don't know why that is. I mean, I'm not hugely concerned. He does make the point that if you use encrypted backups through iTunes, then this file is encrypted. So it's only if
it's on the phone unencrypted, but the backup is encrypted.
Correct. The backup on your Mac is right. Kept encrypted. So anyway, so if someone had access to it and you were concerned with someone knowing where you had been and when, then that's all there. So it does sound like something that we need the option of disabling or manually enabling, or Apple telling us what their plan is for this thing. So in any event, users should know that their phones are doing this. And anyone listening to this podcast and my Twitter feed now knows.
Amazing.
Microsoft has also released a third anti-spyware tool. Now, as our listeners know, my theory of Microsoft's slow march forward is that this is just Microsoft's compromise with people who are selling things for Windows that Microsoft recognizes they actually really do have to incorporate into Windows, but they can't do it all at once because everyone would scream unfair competition and antitrust and so forth. We first saw this with the firewall. I mean, I remember Gregor Frund, who was one of the co-founders of Zone Labs, one of the co-founders of Zone Labs. I remember when he was invited up to Redmond along with all the other personal firewall vendors for a meeting where Microsoft was disclosing that they were going to put a firewall for the first time ever in XP. And I don't know who they were trying to pacify, but they said, oh, don't worry, this is not going to compete with you commercial firewall guys because we're doing inbound only, not outbound, and it's off normally. So most people will never turn it on. And so I remember Gregor and I used to chat on the phone frequently back then, and he sort of scratched his head. He says, well, we're not real happy about it, but they're right that it's really, it's not really going to impact what Zone Alarm's functionality or Symantec's, Norton firewall and so forth. All of the various things. We had Black Ice at the time and other firewalls of that era. But as we know, Microsoft has slowly moved that forward. In Service Pack 2 of XP, now it's on by default. And then now in Windows 7, and I think in Vista, it also does outbound blocking and application level blocking. So today, although it took many, many years and many versions and service packs, they're pretty much done with personal firewalls, and one wonders why you would add a third-party firewall. So I think we're seeing and have been seeing the same thing happening with antivirus. They're very slowly creeping forward, adding features, adding capabilities, and in some cases, the MSRT is the Microsoft. Security Essentials. Microsoft Security Essentials was clearly a big step forward in stepping into this territory. The MSRT was the scanner that we've talked about on a number of occasions, which is updated with every second Tuesday of the month, which they introduced to defend themselves against the problem people were having of updating Windows and then having that crash their systems because they didn't know that they had a rootkit installed, which was assuming fixed entry points for functions, which would change when Microsoft revised the core Windows things. So what we have now, like in the last couple days, is a third thing from Microsoft. Microsoft calls it the Safety Scanner, Microsoft Safety Scanner. You can find it simply by putting Microsoft Safety into Google, and it'll immediately jump to suggest that the third word should be scanner. I do not suggest you use this as a three-word password, however.
We'll talk about that. Discussing
this later. So what this is basically it's built on the MSRT, the Microsoft software removal tool. However, this brings a full and mature set of antiviral, anti-malware signatures with it. It's big. It's 72 megs. And interestingly, it only survives for 10 days from the time you download it. So, but also interestingly, you don't need to install it. It doesn't install. It's a standalone exe called MSERT. Maybe that's for expanded or extended or something. I don't know. It's available in 32 and 64-bit versions and runs from, for example, a USB drive, a little USB stick, thumb drive with no problem. So if you want to use it, the idea being it's standalone, it is a full mature scanner. It's been tested versus the other current commercial scanners, and it has not found to be wanting. That is, it's state-of-the-art in terms of what it finds and sees. And I've already had some feedback through Twitter from some people who have used it under safe mode, for example, to successfully scan and remove malware from their machine. And Microsoft
now, it doesn't replace an antivirus. It's a kind of a different beast, right?
Correct. It is a scan-on-demand scanner, and they say on that page, quote, "The Microsoft Safety Scanner is not a replacement for using an antivirus software program that provides ongoing protection." So, this is the third asset in this arsenal. So we have Security Essentials running all the time, MRT being updated automatically and running monthly, and you can, of course, do, as we know, if you type MRT in the run dialog of Windows, you can get it to come up, and then you can ask it to do a full scan. And this is MRT, but with a full complement of virus patterns. I mean, it's the same MRT dialog. You can ask for a quick or a full scan in the same fashion, and it looks the same from a UI standpoint. So anyway, I wanted to let everyone know that that's there. And for example, if a friend said they think they have a problem with their computer, you could, boot from a CD, boot a safe version of Windows that doesn't have a rootkit installed, and then easily run this from a thumb drive to scan someone's system on an on-demand basis, which I think makes it pretty cool.
Yeah, that's great. Just got a note in our chat room. There's a company called, I think it's a German company called A Shampoo, which makes an anti-malware solution along with other things, office suites and so forth. And they just sent a note to all their customers saying that their customer database had just been hacked. And they discovered it, but apparently a lot of information was stolen, including addresses, billing information, credit card information. Well, wait a minute. I'm sorry. Credit card information definitely not affected. Sorry. So there you go. So it's just email addresses. But we have to add that to your. Don't you have a new section on the show called?
Yeah, and it was empty. So now
well, I just have something for you.
It's the A and B, attacks and breaches section.
There's one. There's one every week, I'm sure, if you really look.
Oh, and actually, a lot of them are like sort of off to the side, or not big. You know, it doesn't quite make it onto the radar. But yes, we're seeing problems, and I'll tell you, it really does seem to be a growing rate and scale of these kinds of breaches now. Yep. Which is why I created a section for it.
Now, I wanted to ask you about this next topic because I use, as you know, I use Dropbox. And Miguel de Icaza, who is a great developer and a really important guy in the open source community, said, what the hell? Because apparently Dropbox has been assuring everybody that they use strong encryption that they can't decrypt.
Well, and that there's two things. There's two issues. One is that Dropbox recently updated their terms of service to say explicitly what was always apparently implicit. Quoting from their new terms of service, as set forth, they say, as set forth in our privacy policy and in compliance with United States law, Dropbox cooperates with United States law enforcement when it receives valid legal process, which may require Dropbox to provide the contents of your private Dropbox. In these cases, Dropbox will remove Dropbox's encryption from the files before providing them to law enforcement. Now, this sums up more perfectly than I ever could why I chose Jungle Disk for my own remote cloud-based backup. And that is, I did a full security analysis of Jungle Disk and verified that all that is ever being put up to Amazon's S3 cloud stuff is pre-encrypted data. That is, my Jungle Disk client has the key and everything it sends. So all Amazon gets is opaque pseudo-random noise that they have no ability to decrypt. I mean, it's full TNO, trust no one as my acronym for this, which is the only way I would ever store something in the cloud. So here Dropbox has formally acknowledged that they have the ability to decrypt the contents of all of their users' data, and that they will do so when ordered to by a court order from the United States.
So as Miguel points out, well, if they can do it by court order, then they've had that capability all along. So they essentially misrepresented the encryption capabilities.
Well, and see,
he says this is a larger issue, not so much government, but that means employees could do it. And even with a company that has very strong data policies like Google, we see these things happen.
Very, very good point. It means that, keys could get compromised, keys could get lost, or, as you say, you could have a bad Apple employee who, realizes, hey, we're hosting a celebrity. I wonder what he's storing in his Dropbox.
So I make sure I don't put anything of a private nature on my Dropbox, but I'm going to make sure I don't. And you're right. I think if you're going to do it, if you want to store something like financial records, use Jungle Disk.
Well, and here's another, and this works too.
Pre-encrypt.
Exactly.
Yeah.
Only store stuff that you have encrypted up there where you're pre-encrypting that data. And this is why when I see someone saying industry standard, AES 256-bit encryption, it's like, that means nothing. I mean, it's, unfortunately, it catches out people who don't listen to this podcast, who assume that if you're using state-of-the-art encryption, then you must be safe. No. I mean, I would imagine that means that the link is encrypted, and it does sound like they're storing it in an encrypted fashion, but they're storing it with a key that they have. So that doesn't really help.
Yeah, that's the question. Who has the key?
Right.
Yep.
And the best solution is for no one but you to have the key, and the only way to do that is to pre-encrypt and only store encrypted stuff in the cloud. Now, the other issue that came up was a question of their authentication. Someone named Derek Newton, who's a security researcher, was poking around in Dropbox-like applications, and he just decided he would take a look and see what they left behind, what was left behind after they installed. What he found was that specifically in the case of Dropbox, there is a single file called config.db, which is an SQLite database file, which contains the email address, the Dropbox path, that is where the Dropbox folder is on your system, which is being synchronized to the Dropbox in the cloud, and the host ID. Any SQLite DB compatible client is able to open this file and look at it. And what he determined by experimentation is that the only thing that identifies you to Dropbox is the host ID. There is no other lockage of that file to a given system. And so what he posted, and again, I learned about this from people saying in Twitter, hey, Steve, what do you think about this? And this has been a constant flow for the last couple of weeks. And I mentioned last week that I hadn't had a chance to dig into this, but I would, to look into it and verify it. So I did want to follow up for everyone who's been wondering. So again, so what this means is that if you weren't protecting this file, or if anything got onto your system which was able to grab this file through social engineering attack or spyware, malware, whatever, if you lost control of that file such that it was in any way exfiltrated from your control, then that file can be installed on any other system, and that provides this sole authentication of you, the instance of you to Dropbox, such that with no other information, no username, password, no logon, anything, that authenticates that new system, and it doesn't appear as a new machine in the set of machines that you have authorized to use. It's merely a clone of that first one, which then has full access, unencrypted access to your Dropbox contents, which to me says these guys aren't really looking at security. I mean, on one hand, we know now that they can decrypt the contents of our Dropboxes, and this could clearly have been done in a way that was more secure. Even if the user changes his username and password, that doesn't invalidate the host ID. It still functions. And so if somebody had it, it's that their connectivity survives across the user changing his username and password. So it's just, they really could have easily done a much better job of, hashing username and password into this, tying it in some fashion, for example, to the serial numbers of the hard drives on the system. I mean, just anything to make it more difficult than simply one file which you can put on any machine anywhere, and suddenly it's authenticated just as solidly as the system it came from.
Yeah, that's not
so good. Not good news over on the Dropbox side.
There are alternatives. LaCie has a similar service to Dropbox. It's Java based. I don't know if it's more secure, but I think maybe it's time to look and see what the other alternative. I love Dropbox, and I hope they respond to this by making it more secure. That would make everybody happy.
I think they can. I mean, one would imagine they will, because it's so trivial. I mean,
yeah,
all they have to do is listen to this podcast for a while
and add some encryption features. The other one to look at, I'll take a look at, is from LaCie. It's called Voila. Randall Schwartz told me about it. It's WUALA.com. Very similar to Dropbox. I'll look and see if when they say all files get encrypted. See, that's the thing is, get encrypted. But what does that mean? Where is the question?
Yeah, exactly. I mean, and that's just it. Unless there is a full security analysis available of how it works and what it does, you just can't trust it.
Here's what Walla says. It says, all files are directly encrypted on your desktop. Your password never leaves your computer. Not even we as a provider can access your files or your password.
Well, that's all good sounding.
That's what you want. You
Yeah.
got to validate it, of course.
Yeah.
Well, I'm going to take a look at them. Randall Schwartz recommended them. He likes them a lot, so I'm going to take a look at them as an alternative to Dropbox.
So under my miscellaneous category, I did note, and I just got a kick out of this, that Bitcoin's BTC, which is the three-letter acronym for the currency, the Bitcoin currency, Bitcoin's currency to U.S. dollar exchange rate has reached a new all-time high of 1.12, that is $1.12 per Bitcoin, on one of the major Bitcoin exchanges, which was MTGOX, the @MTGOX market. So I just thought I would let our listeners who are following Bitcoin and interested knowing that Bitcoins keep getting more valuable, ephemeral as they are. So
more valuable.
More valuable. Well, I mean, you can trade them in for dollars. You can get actual dollars.
But that worries me. That worries me. I feel like that's money laundering by somebody, somewhere.
Well, that's privacy. Isn't that a good thing?
No, but I got to wonder who's buying Bitcoin for real greenbacks and why.
Yeah, I don't know. I just think it's cool technology, and it works. Yeah. And we have a full security analysis of it, and I can vouch for the fact that
Bitcoin's good. So, I'm not saying that. The only thing that worries me at all is this notion of there being a market for greenbacks.
Yeah. So I've been getting questions, mostly over in the GRC news group, about when GRC would offer Shields Up style analysis, port scanning, on IPv6. And so I contacted Level 3 and I said, hey, what does it take to get some IPv6 block? And they said, all you have to do is ask. Are you ready? And I said, not quite yet. So then I called my local T1 provider. I have, as always, 2 T1s coming here into me. And for the first time, really, in a long time, I'm glad I've got T1s. Because I don't think Cox or Community Cablevision or whoever does my cable modem, I don't think they would know how to respond to this question at this point. You know, ultimately they're probably going to have to, but I don't even know if they'll make IPv6 service visible to their customers. Who knows what they're going to do in order to actually, roll this out. But I have a direct connection with Cogent, who is my provider of connectivity on the other side of my pair of T1s. And the engineer from Cogent has been with me since before Cogent bought the T1 business from Vario. You'll remember all that, Leo.
Oh, yeah.
And so I said to them, hey, I'd like to have IPv6 service. The idea being that I'd get it here at home and, /office where I hang out and work, and update my router to handle it, because I've got an old Cisco router, but there's firmware available for Cisco's iOS, and there was a name collision, of course, with Apple's iOS, but Cisco is there first. Cisco's iOS has been able to handle IPv6 for many years, since I think 03, and so I'd update that and my various other stuff, and then begin to perform some experiments and bring myself up to speed and write some code and be able to support IPv6 access of Shields Up. So they'd never done that before when I asked them, which gives you some sense, and this is just in the last couple of weeks, gives you some sense for where IPv6 still is that, Level 3 wasn't pushing it, but they did say that new deployments of large customers, when they were setting up new people, they were all often using IPv6, though still with some IPv4, but, IPv6 was in the conversation. Over the course of a week or two, because I know the engineer at Cogent, they were able to move things around and provide me with IPv6 service. They gave me a choice of how many IPs I wanted. Is everyone sitting down?
Yeah, yeah.
The normal allocation for a customer, the typical sort of like minimum that you get if you've got a network is a /64. Now,
how many addresses is that?
Okay, IPv6 uses 128 bits of addressing. So a /64, and this is the normal networking that is used, is 64 bits for the network number and 64 bits for the machine in the network. So we're used to this notion of there not being a fixed division between the network and the machine. So, for example, we have like, a /24 will be 24 bits for network. And since in IPv4, we have a 32-bit address, that leaves you with 8 bits for machine. So, for example, the famous 192.168 dot something, well, technically that's a /16 because you have dot something, but it's normally used in a /64 mode where you'll have 192.168.0 dot something, meaning that only the last byte in that network is set to which machine you have, so that you can have 253 machines on that network, which is more than anyone has at home typically. So but this changes when we move to IPv6, just because the reason we began to constrain the size of the number of machines in the network was that it gave us many more networks, and we started to we needed that variable boundary between networks and machine numbers because we were running out of available networks. So they sort of pushed that boundary downwards, making each network smaller so that we would have more networks. Which is probably the best way to say it. But with 128 bits of addressing under IPv6, we don't ever need more networks. So typically, they're going to just divide the 128 bits of IP space in half and not argue about it. You get a 64-bit network often if you're like a regular customer with an ISP. So that's 2 to the 64 different IPs. And I did the math earlier. I don't have it in front of me, but it's billions of machine. Wait, 2 to the 64. I can do it.
you got your programmer's calculator there?
You bet I do. 2 to the 64 is
a lot.
1.8 times 10 to the 19.
Whoa! That's pretty big. That's how many
8.
IP addresses you get?
Yes. Now, well, actually, no. That's what most people get.
Oh.
John said, well, Steve, if you ever needed to, renumber yourself, then we would make you move to a different /64. So we're going to give you a /48.
Oh, well.
Okay, so that's
lowers more.
Yes, that's the 48 is the number of bits they have over on their network side. So 128 minus 48 is the number of bits I have.
I get it.
So I have 80 bits, which is 1.2 times 10 to the 24th. Now, okay, so 10 to the 24th, that's 24 zeros. Now, a million is 6 zeros. So this would be 4 sets of million. So 1.2 million IPs I'm going to have. Now, I don't know what I need all those for, but, John
it just shows
said,
you how much there is.
Yes, that's why I wanted to illustrate this. It's just, it gives us a sense for, and you can imagine in an environment where we're all running out and everyone's, oh, no, the sky's falling, IPv4, now the registries have run out, now blah, blah, we're hearing all this. So you'd think maybe they'd learn the lesson and be a little more parsimonious with these IPs. It's like, well, how many do you really have over there? How many do you need? But the point is, even in this climate of, well, we ran out of IPv4 space, so we don't want that to happen again. But with 128 bits, they're just saying,
take all you want.
You can have.
There's plenty.
You've got, 5, 6 computers over there? We're going to give you 1.2 million IPs where you can just get lost. I can't even write that down. It's more of a burden than it is a benefit. But so it's funny, too, because then I wrote back. I said, okay, John, how many do you have? Because, he just seemed to be peeling them off with such alacrity. How many do you have? And he said, well, we received a /32 from Aaron, that's the North America registrar, and another /32 from Ripe, which is the European one. So /32 means 32 bits of network, and then they have a 30. So the 32 bits are fixed, and their number is 2001:550, which is a way of, in IPv6 parlance, and we'll be discussing all of that in the future, that's their network. They then they can do anything they want to with the balance of the bits out of 128, and since 32 from 128 is 96, they've got 96 bits that they can allocate any way they want to. So, for example, when they gave me a /48, they have 65,538 networks of that size. They have
Wow.
65,000 /48s, of which they're giving me one. Most people, they'll give /64s, so they've got vastly more of those networks. And actually, they have another 6 that gives them. If they use 64s, that gives them another 16 bits of allocation. So that's another 65,000. So they're just not worried. Oh, and if they do actually run out, they just ask for another one.
Because there's plenty.
Yes, well, there are 4.3 billion of those /32 networks, because we know that /32, think about that, /32, that's the total number of IPs that we have now in IPv4. That's the total number of networks of that size that the registrars can just peel off at will. 4.3 billion networks, each containing 65,000 /48s.
Wow.
So, yeah.
We're fine. In the words of Tom Mahomey, you sound like Carl Sagan. Billions and billions of IP addresses.
I did love this. He said in his note, he wrote, so customers really, if they can have a 48, a 56, or a 64. He says, to get a /47, which would be like, one more bit above 48, because you're squeezing the network side down to get more machines. He says, to get a /47, a customer would have to prove a need, parens, which no one has done yet.
Or will ever do.
Okay, because yes,
try and prove a need for a 64. That's more than the whole internet now.
Oh, exactly. That would be needing 1.4 times 10 to the 14th individual IPs. which, as you said, is like many, many, many millions of internets now.
An
So
unusual
that'll never
application
happen.
I'm going to be signing.
And I've got to say, as I was thinking about this in the context of Shields Up, how many times have we run across situations where a problem was that it was possible to scan? That is, NIMDA and Code Red and Blaster, they used to be scanning the internet. And even though we think of 4 billion IPs being a lot, if you've got a botnet, for example, you can scan a lot of IPs in a relatively short time. And that's one thing that dramatically changes, because it's no longer the case that a large percentage in a small region of allocation are going to be valid IPs. You have 128 bits, they're going to be relatively sparsely allocated. I mean, I'm going to use, a handful of IPs out of, actually, I'm behind some powerful natty kind of stuff. So
yeah, you don't really even need more than one, yeah.
Yet, here's this massive block, which is all given to me, and God help something that tries to scan that. So scanning really...
that's a good point.
Yeah, scanning, the nature of scanning really does change in an IPv6 world. Now, you might argue that, well, you just scan the, 0, 1, and 2 of each range. Well, but I'm not going to put my IP, the one I use, down there.
Right.
It's going to be floating hidden somewhere in the mist.
Up there in the billions.
Oh, yeah.
Wow, that's so cool. I just hope this all happens. That's all. I mean...
Yeah, that'll be fun to talk about.
APNIC ran out of IP addresses, IP4 addresses. So.
Yep, and there sure is some reluctance for it to happen. Otherwise, Microsoft wouldn't be, offering millions of dollars for Nortel's block of IPs. Clearly, there's some reluctance to make this move.
Yeah.
So, a customer of ours, of GRC's, David Ward, I guess he has a computer company called Wellmax Computer. He just wrote a short note that I wanted to share. He said, I had a friend bring a laptop to me and tell me that the fan was failing. The machine would freeze after about 5 minutes into the Windows XP boot process. Wow, it was taking more than 5 minutes to boot? Anyway, he says, he had taken it to 3 other techs before me who all said the same thing, that the fan was failing. So the machine was overheating and then stopping to boot. I experienced the same problem. However, after booting into safe mode, I experienced the same problem, however, after booting into safe mode. And having the machine stay on for an hour, I knew this was not a fan issue, but a hard drive issue. Sure enough, after running Spinrite for over 180 hours, he said, parents, it's okay. At one point, it said it had another 1,089 hours to go. Because remember, it estimates...
It's guessing, yeah.
Yes, it estimates how long it's going to take based on how long it's taken so far. But often, bad spots are in the beginning.
Right.
And so things, pick up the pace dramatically after Spinrite deals with the early problems. So he says... it finally finished after finding and fixing many bad sectors. Now, the machine booted successfully and ran very well. All the customer could do was shake his head and utter the phrase, amazing, several times.
Oh, that's great.
Thanks so much, David Ward, Wellmax Computer.
Amazing.
Amazing. So thank you, David, for your testimonial.
So I tweeted this. I think I saw it in Hacker News. It's funny because I didn't realize it was a 4-year-old article, but a fellow named Thomas Beedkal, I think that's how you say it, in Denmark, published an article on his blog 4 years ago, which has gotten a lot of attention lately, saying, who needs those really hard to remember random punctuation passwords where you could just use 3 common or uncommon English words and do better? I believed it. Looked good to me, but we've got to give it the Steve test. Steve Gibson is going to explain why 3 English language passwords may not be the best solution. But first, I want to tell everybody about Netflix. We're going to get Steve We're going to get Steve. One of these days, one of these little red envelopes will come to his door, and he's going to say, all right, finally. Netflix, of course, everybody knows Netflix is the DVD by mail company. That was what they started doing. Reed Hastings. We got to get Reed on one of our triangulation episodes because he's a fascinating guy. He had the insight in a computer science class in college when the professor says, what has more bandwidth, a fiber connection between the New York and Chicago, or a truck loaded with DVDs? And in fact, the truck loaded with DVDs probably does have more bandwidth because you get an awful lot of data on these DVDs. Reed said it's not so bad to mail DVDs, especially if you can, as Netflix does, get them to the customers within one business day. I mean, that's pretty remarkable. In many cases, you just pop that DVD when you're done in the mail, and the next one's there in a couple of days. I love that. I have the 5-disc at a time subscription. They have 1 disc, 2 discs, 3 discs, 4 discs, 5 discs. But they just announced a couple of months ago, and I think a lot of people are moving to this, a streaming-only subscription. They have, Netflix Instant Play is amazing. Works on your Mac, your PC. TVs that are hooked up to an Xbox, a PlayStation 3, a Wii, a Roku box, a Boxy box. I mean, all of the boxes. Many TVs now do it themselves, have Netflix built in. It's kind of the gold standard on a TV with internet connection. Blu-ray players almost all have Netflix built into it. So you can watch Netflix streaming movies on your big screen. I do it every night. And, when you said billions and billions, I thought of Carl Sagan. And I thought, I would love to see Cosmos again. Remember that, Steve?
Yeah.
What a great show that was. So I thought, I'm sure they have it on DVD on Netflix, and they do. But they also have it for Instant Play. So this is why I love Instant Play. You could get that, that bug. Oh, I would really like to watch a movie tonight or a TV show tonight. And you can. You just click play, and it's playing. I actually won't play it now because I'll probably violate copyright in 800 Ways from Sunday. But I think this is such a great solution for people who are looking for an affordable on-demand solution that with great quality. If you have enough bandwidth, and most people do, I get 720p high def. It looks great on my 60-inch display. So many great movies. Netflix.com/twit. You could sign up today and get a month free just to see. Just to see. And one of the other things Netflix does really well is recommendations. I always rate the movies, and then it'll give me recommendations based on my ratings. And I find, here's a British sketch comedy show I probably never would have heard of. But it says, based on your interest in The Big Lebowski, Monty Python, and this is Spinal Tap, you might like that Mitchell and Webb look. Pop culture parodies, mockumentaries, game show spoofs. Yeah, I might. So the recommendation engine means that you'll never be wanting for something to watch. Tens of thousands of movies instantly streaming, movies by DVD, and all of this free for the next month when you go to netflix.com/twit. Billions and billions of movies. Well, maybe not that many, but certainly quite a few available to you instantly. You see the last 3 things we watched. Family Guy. I think that Henry and I watched that. Best in Show. By the way, they have something like 180 Family Guy episodes on here. 127 episodes. Best in Show. What a great mockumentary that was. The Big Lebowski. What a classic that is. Henry said he didn't like it. I don't care. I give it 5 stars. This is why Netflix is amazing. It is on demand done right. Netflix.com/twit. Give it a try today. We love it that they're part of the Twit family. I've been trying to get them on here since day one because I've been a Netflix. I'm so surprised that you're not yet a Netflix customer, Steve. I've been a customer of Netflix for, I think, since they started. I mean, I'll have to look and see on my account.
We know how much inertia I have in my fundamental operating mode. I'm here in front of Service Pack 2 of XP, and and I finally moved from IE to Firefox, and I'm just a disc buyer. I have a huge DVD and now Blu-ray collection, and because I do like to watch things multiple times over.
But that's the beauty of this.
The years, yeah.
By the way,
I'm not saying it's right. I'm just saying it's inertia.
I see that I have been a member since November 2000. So
yeah, you are our favorite early adopter.
I jump on this stuff. And I just love it. I mean, it'll be 11 years in November. That's even longer than I've been a member of Audible.com.
I did hear that this whole notion of online delivery is picking up so much steam that there's some movement toward major release movies becoming available not with a multi-month delay, like not when the discs are available, but like much sooner.
Because, first of all, they don't have to print a bunch of discs, but also there's no issue. Piracy is not an issue when you're streaming. So the movie companies are so sensitive about sending out discs. You know, another thing Netflix done, which is very interesting, they're starting to produce original content for Netflix. They see this as the future, is original content streamed direct to you. I think they're brilliant. Somebody in the chat room, Rouston saying in the chat room, I can't live without my Netflix. Yep. Me neither. I wouldn't dream of it. All right, let's talk. 3 words. This is fun. Is that a better password than ASIW greater than? No?
No, in fact, that was one of the conclusions in bold on Thomas's page. He says, this is fun is 10 times more secure to use than capital J, numeral 4, lowercase f, uppercase S, less than, numeral 2. Now, just look at what it took me to communicate the second one versus this is fun.
Right.
And that gives you a clue. But let's start
get
a little
science.
bit
Let's do the
further.
math. Yeah.
Yeah. So once upon a time, we had the notion of a password. And we understand that became unusable, unsafe, because of dictionary attacks where, well, first of all, people, famously would use the word password as their password, or, all nines, or 1, 2, 3, 4, 5, 6, 7, or, they're something guessable by somebody who knew them. There were all kinds of reasons. So then we sort of, in my own thinking, evolved to passphrases, where you had the notion of longer is better. And that was sort of where my own thinking moved through, with this notion of something that was memorable. But then in thinking about it more, and also literally doing the math, I moved to passcodes. And our listeners have heard me referring to passcodes now for some time. And so the question is, what about short pass sentences? Does that make sense? So let's back up a little bit and look at the attack model, that is the threat model for the use of passwords. I think this whole thing, the whole notion of something the user knows as one factor of authentication remains important, because not only is it the original technology for online authentication, but sadly, we're seeing such slow adoption of other things like the YubiKey or the smartphone-based one-time password technology. I mean, we have all the technology that we need to solve the problem, but it's just adoption rate. And what's interesting is much could be done to strengthen even the use of passwords, much more than has been done. And what I'm hoping we're going to see is that happening over on the server side. And we'll talk about what that is, because that's a function of sort of this password technology. So we start with something the user knows, which is the idea being that it's a secret. And obviously you'd like it to be unguessable by somebody who knows you. You'd like it to be not easily brute forceable, like not a as a password. So as we've talked, there are 2 technologies essentially for a user's interaction with logging in online. At the server side, they either store the password or they hash it, and then they store the hash. The idea being that unless you're in France, where there seems to be some legislation requiring that the user's password itself be made available, unless that's the case, there's really no need for an authentication system to store your password. What you can store is something which you can uniquely derive from the password, and that provides some privacy protection for the user, because we have the cool cryptographic technology now known as a one-way hash, a cryptographic hash that can take a password and turn it into essentially a pseudo-random token, for which there's no way to reverse that process. You can't go backwards because it's inherently an information lossy process. So that allows an authentication provider to just store that hash, and when asked to re-authenticate, the user provides the same thing, which gets hashed in the same fashion and produces an identical result, which can then be compared for identicalness. That prevents someone from saying, well, you almost got it right, you didn't get the punctuation correct, or you didn't get the capitalization correct. There's no way they can do that. All they can say is, nope, that's not what you gave us before, try again. Now, cleverly, rainbow tables were developed as a means of getting around this one-way hash concept. A rainbow table is essentially a dictionary of all the results of hashing everything. So you sit there in what's called an offline mode, and we'll make that distinction very clear in a minute, an offline mode with your field programmable gate arrays, your graphics processing units, your GPUs cranking away, whatever it is, or you network this among a whole bunch of people producing rainbow tables. The idea being that you just brute force everything through the hashing function, and you store in a database, a huge database, like a terabyte database, the result of all of those hashing operations. In that case, if you ever do get access to the result of the hash, you can look that up in this rainbow table, and it provides you the reverse direction, only because it did all of the forward directions and it saved them all. That allows you to essentially look up the result of the hash and figure out what you could input that would give you that result. It turns out the good news is that's easily defeated too. All you have to do is add something, which in cryptographic circles we call salting. You add some salt to the hash, meaning that you take anything, and it could just be some hopefully not easily guessable blob, and you always append it or prepend it, whichever, doesn't really matter, or even mix it in with what you're going to hash, which essentially produces a custom hash function. It's the way to think of it. A salt gives you a custom hash function so that with your particular salt, no one else's rainbow tables will work because you've mixed something in beforehand. Now, if they did get access to your salt, somebody could generate rainbow tables for that, but that's sort of that's a different problem. It prevents a single, like an SHA-1 or an MD5 hash, which are well-known public uniform hashes. It prevents just rainbow tables for being generated for those hashes. And by the way, those exist. They're big, but they're available on the internet, rainbow tables for those hashes. So you would never want to use those without adding some salt. When you do, it makes those existing pre-created rainbow tables obsolete. Now, I talked about online versus offline. The reason this is important is it's a function of how many opportunities an attacker has to test a password. If something is offline, that is to say it's, for example, TrueCrypt. We've talked about cracking TrueCrypt. The idea would be you have a hard drive that you want to encrypt, and it is unfortunately subject to an offline attack, meaning that an attacker could set himself up so that at an extremely high speed, they are presenting to the TrueCrypt algorithm, which remember is open source, so there's no secrets there, which wouldn't make their job impossible if it weren't open source, but it's just easier that it is. They would present to that algorithm every possible password they can come up with as fast as possible, run it through TrueCrypt's front end to create a key, and then see whether that key decrypts the beginning of the hard drive, like a hard drive sample that they have taken. And the point is that nothing theoretically prevents them from doing that at an incredidly high speed.
Well, doesn't a good program, I would imagine TrueCrypt would slow them down. I mean, I know SSH slows you down. Doesn't TrueCrypt say, oh, you've made 10 guesses, let's wait a minute?
Well, actually, TrueCrypt itself could, but the algorithm, but the problem is the bad guys can simply, since it's open source, they have access to anything that does that.
Yeah.
And they could just short circuit it.
Got it.
So the problem is in an offline attack like that, where you have access to everything, and you know, cracking DVDs is the same thing. Anything offline, then the idea is that it scales linearly.
Right.
That is, the more processing power, the more GPUs that you bring to it, the more you can try. But notice that online attacks are completely different.
Oh yeah, and that's what he's talking about. We should say.
Yes. Well, he discusses the issue, but yes, he says,
is assuming in all of his calculations you could do 100 tries per second.
Exactly. Now, I think that that's probably very generous.
Yeah, it's way fast.
Yeah, because, you know, we know that when we're trying to log on to something, we, you know, put our username and password in, click, you know, submit, and we kind of sit around and wait for typically a couple seconds, you know, whether we're right or wrong, before the system comes back and says, oh, that's correct, or oh, nope, sorry, you know, something's highlighted in red, that your username and password don't match, try again. So my point is, and this is really
by the
crucial.
way, somebody claiming to be Baked Doll is in our chat room, so I'll watch what he says and I'll give you his feedback.
And I think it probably is, because he did see that I was going to be talking about this, and he did send me a tweet yesterday because he knew that I was going to be talking about this.
Yeah, and as we mentioned, he's not a security expert. He's a new media guy.
Well, and he makes a number of very good points, but I would only take issue with the notion that 3 simple, short English words are more secure than something completely random. And I can do the math.
We're going to explain it. Yes,
exactly.
But so far, so good. He's made a very conservative assumption, which is that you'd have 100 shots a second at this.
Well, okay. Now, maybe if you, and this would be a function of the way the website is designed, you might be able to have like 100 clients or 100 agents all connecting to a web service at once, trying to get into the same account, in which case that would scale up your rate. But no matter what, you've got internet round-trip delays, you've got lost packets, you've got, you know, TCP retransmissions, there's like substantial overhead which scales back dramatically the number of attempts that any kind of brute force guessing is able to make, which dramatically changes the math. And this is, more than anything, that's the point that I would like to get across to our listeners, is it is very different to choose a secure password for an online service where the attacker would be reduced to an online attack versus anything like TrueCrypt or an attacker that could do an offline attack. Now, this isn't an absolute, because as we mentioned earlier, and we do talk about weekly, it is often the case that databases are being stolen, and so an online service whose database was stolen could then be subjected to, could have its accounts subjected to an offline, that is to say, very high-speed attack. So it's not necessary. We can't guarantee that an attacker would be using the same online transaction delay that we are, but I think it's a reasonable assumption.
Okay.
So
whatever he says is we're talking about in the realm of attacking a web password.
Yeah.
Without physical access to the server.
What we really need, when I talked earlier about some changes that could be made that we're in desperate need of having made, and that is that in an online scenario, and you mentioned something a second ago.
What?
that introduces a delay.
Oh well, a lot of programs do. I mean, on the Mac, SSH, a lot of programs do.
Secure shell.
Yeah. Or if you're logging into your Macintosh, if you enter the password twice or 3 times wrong, it just pauses. It doesn't pass very long. Yes. It gets longer each time, but it pauses.
And of course, Unix and Linuxes have done this for time immemorial, and specifically to prevent this kind of brute force attack is all you have to do. In fact, you could make the time delay exponential, where each time you guess wrong, it doubles the length of time you have to wait. Well, we know how quickly powers of 2 pile up,
right.
And you don't even have to set a fixed lock on or lockout. When I was designing my e-commerce system, I was very conservative, and if somebody messes around with the e-commerce system in a way that my system detects doesn't make sense, they're blacklisted. I mean, it's like I don't care. I'm sorry about that. And we've had some complaints from people who seem unable to type their name correctly.
No Spinrite for you.
And so and again, I have no problem then with handling that through a human interaction loop, but we certainly don't want to allow an automated script of any kind to be able to pound away. So that is lacking to an alarming degree in today's websites. And that is something so simple to fix. If it was just universally applied, that like a progressively longer delay was present. Now, the flip side is they know that's going to cause some customer support problems, and so that tends to, to work against them doing that. But it's so simple to do, to introduce that delay of response on the server side, and radically scales up the security in the face of anyone trying to do an online attack. So the question then becomes, what's more secure or less secure? And again, I'm not meaning to be attacking Thomas at all. That wasn't my intent. But many people asked if short English words were more secure than a short bit of gibberish. Now,
and that's his assertion. So that's what we want to know.
Now, one of the things that I have referred to when we're talking about passwords in the past is something that is a point that Bruce Schneier made that I thought was really astute. And Microsoft's own security people have said the same thing. They've said the danger of using something that you can remember is that it's going to be too simple, because it's difficult to remember capital J 4, lowercase f, capital S less than 2. That's arguably difficult to remember, more so than the phrase "this is fun." And so Bruce's point was that use something difficult to remember, which you write down and stick on a piece of paper in your wallet. And he made the point that we already know how to secure and manage little bits of paper. We do it. We have a wallet. That, we know how to handle that. more so than something which is easy and memorable, but as a consequence of that sacrifices security. So in the tweets that I received from people asking me about this, they were using different little 3-word sentences. Thomas on his site uses the sentence, "This is fun." The problem is that the issue in terms of bits of vocabulary size and the strong tendency people would have to design a sentence which makes sense. That is, they would not tend to choose 3 truly random words from a really large vocabulary, because, aardvark has 2 A's, and who can remember how to spell that? Or, tapioca might be a problem, and so forth. So what in the samples that people were sending me, they were using 3 words from maybe 1,000-word, conversational vocabulary, for example. Well, we know that, if you took 3 words chosen purely at random from a set of 1,000, well, that would be 1,000 times 1,000 times 1,000 possible sentences. So there were at 10 to the 9th, or 1 billion possibilities. So 1,000 million billion. The problem is that if you instead were to choose characters from the full ASCII set, that is to say, lowercase alpha, that gives you 26 characters. Uppercase alpha gives you another 26. The digits, 1 through 10, gives you 10. And just the characters available on your keyboard give you another 35. So that's 26 plus 26 plus 10 plus 35 is 97. So that means that if you randomly choose a random character from an alphabet of 97 characters, and you used, for example, a 6-character token, which is what Thomas uses in his example, that would be 97 to the 6th power possible combinations, which compared to taking 3 words from 1,000-word vocabulary, which gave us 1 billion combinations, using just 6 characters is 833 billion combinations. So 833 times stronger, all other things being equal. Now, you could argue that, okay, wait a minute, the weakness in the argument is this 1,000-word vocabulary. But it turns out, even if you used a 500,000-word vocabulary, which is the number of words in the English language, for example, it turns out that doesn't scale much faster either. 500,000 words in the English language is 18.93 binary bits, and then if you use 3 of those. But to do that, you're using really obscure words. So my feeling is that while it's tempting to use memorable sentences, short 3-word sentences, the problem is that we want to have multiples of those. We know that it's much safer to use not to reuse the same password on different sites, which is why, of course, LastPass famously solves this problem by giving us a local database which is locally encrypted and is able to figure out what domain we're trying to log on to and fill in these forms for us. So it solves the problem of a pass anything, whether it's a pass code or a pass phrase or pass sentence, on a per site basis. If we're going to be using different sentences on different sites, then we still need to write them down to remember which sentence we used on which sites, because many of us are logging into all kinds of different services throughout our day. And that number of servers is increasing. So we still need to have something written down to disambiguate, and that assumes we didn't have LastPass, which sort of solves the problem for us anyway. So I guess my feeling is that if we're going to use a single short sentence across the entire internet, we know that's not safe.
Right.
And if we're choosing it from a small vocabulary, it doesn't give us as many possibilities as, oh, and again, you can of course add words. It doesn't give us as many possibilities as using a short token from a much larger character set, or from a full-size character set. 97 characters, for example, are available on an English keyboard, and that there isn't anything wrong with this notion of writing it down, because if we're going to use different ones for different sites, then we need to write them down anyway in order to remember which one we used where. So I wanted to respond to everybody who was saying, hey, Steve, what do you think about this? You know, this seems, you know, wouldn't it be great if this was really secure? My feeling is, well, if you want to use short sentences, make the words really obscure. Now, the other thing that I didn't touch on is, notice that in the case of "this is fun," well, that makes grammatical, semantic sense. And that's another huge weakness of the whole sentence problem. And that is, you know, we didn't use, you know, barnacle itch robbery as our three words. We used "this is fun." And in all the examples that I've seen people sending me, their takeaway from this was
use "this is fun."
Yeah, well, or
something grammatical.
You know, I like tapioca.
Right.
Now, sure, it could be I hate tapioca, I despise tapioca, I slurp tapioca. I mean, you could have different things, but notice if you impose the filter of "this makes sense," this is a grammatically correct sentence, now you have hugely changed the odds in favor of the attacker, because there are out of the, for example, in the case of a 1,000-word vocabulary, you know, a conversational vocabulary, 1,000 times 1,000 times 1,000, that gives you 1 billion. Well, only a small fraction of those billion possible arrangements of 3 randomly chosen words makes sense, would actually be a sentence. And although we don't know that it exists today, we can imagine if this became in vogue, that the extension of the classic dictionary attack would be the sentence attack. Right. That it would be an English sentence generating algorithm that chose words starting with small ones, and then, you know, ramping up to larger ones, very much doing sort of a brute force sentence attack, which is completely possible.
But what if, for instance, instead of using spaces in "this is fun," I used an arbitrary punctuation of my choosing and something easy for me to remember, let's say %, and I wrote "this % is %fun." It strikes me that we're not saying, I mean, Bechtel says it's computationally more difficult. We might dispute that, but it's certainly difficult enough, isn't it?
I really think so. Yes, anything you do to obscure. Now, the other thing you can do, and we didn't talk about this, is case sensitivity. You would want to make sure that the system receiving the password was case sensitive. There are some, for example, that are deliberately not. For example, I remember when I was talking about LastPass.
Banks.
Well, but LastPass, right, the password is definitely case sensitive, but they deliberately lowercase the email address, which is the other portion of what you use to identify yourself with, right, because email addresses are not case sensitive themselves. So they felt that they would have a problem with users who might formally, you know, use a capital for their first letter of their name if that appears in their email address, but then, you know, either use it or not use it when they were logging on, and that ambiguity, since email doesn't care, they didn't want their system to care. But yes, Leo, as you made a point, we know that there exist systems which are deliberately case insensitive because they want to ease the logon burden of their users, and in the process, mess up their security. So case is less strong, for example, than the use of
punctuation or numbers,
punctuations and numbers instead. Right. And in fact, you could also go hacker-esque and use numbers instead of letters that look sort of the same. But again, I mean, I guess my feeling is the bottom line is if it is too memorable, it is too easy. Because it is its memorability. Memorability?
Yes, memorability.
Memorability. Yes. So that didn't sound right somehow. It is its memorability, which we like, but that to me that says somebody else could guess it. Right. Somebody else would have some reason to include it in some big corpus of things that they were testing against. Now, the one thing that completely changes everything I've just said is that we're assuming knowledge on the part of the attacker that they don't have. That is, no attacker knows anything about the scheme the user could have used. That is,
and it would probably be foolish for them to make assumptions about that.
Yes, because there are an infinite number of schemes available. So and that's one of the things that Thomas did on his page. It was a little misleading, where he talked about the comparative strengths of different passwords. He showed like all lowercase as opposed to random symbols, and said that the all lowercase one was weaker. Well, it's only weaker if the attacker knew that your password was from a limited character set of all lowercase. If the attacker didn't, and they still were having to try all possible characters in all possible character positions, then all lowercase is no weaker than random symbols, because the attacker doesn't know what you've chosen. So anyway, my feeling is, yes, Leo, you could use words if you do something to obfuscate them, and the attacker will not know what you did.
But there are the two issues, one of which you raised, which is that if you use words, you're going to be tempted to use that password all the time or on more than one site. So that's a bad weakness.
You're going to be tempted to use non-random words in a sentence, and as soon as you do that, the strength of what you have done just collapses.
Right. And because so that's the same problem essentially, which is memorability is anti-security.
It implies a weakness.
It's a weakness. And then there's a second issue which the chat room raised, which I thought was quite astute. If you use something that is a phrase and somebody sees you type part of it, they are a lot closer to guessing your password than if you use random letters and numbers.
Very good. Now, and Thomas did on the side on his side, he made a point which I did like, and he said if you use words, you can probably type it in easily and quickly.
Yeah.
And it's like, well, that's a good point. You would be less prone to typos than if you're trying to type capital J 4 lowercase f capital S less than 2. On the other hand, I've much got that memorized by now, and I think all of our listeners have as well. Don't use that one.
And of course, all systems like LastPass, KeePass, 1Password, RoboForm all use a master password which does not change. That might be a good candidate for a passphrase that is memorable to you. I tend to use longer passphrases than 3 words, and I also like to put punctuation in, commas, exclamation marks, and I capitalize. So all of that makes it more difficult to guess, especially if an attacker doesn't know I've used a passphrase.
And the one other thing that we've talked about before, but I'll remind our users, is never write the actual password down
on a Post-it note and put it on your monitor.
Well, no. What I meant was do something to it so like in what's written down. For example,
hash
always
it.
leave off always leave off the first or the second characters, which you know to put on,
Right.
but no one who discovered that written down would know.
I actually
They
do
would,
that.
if they got a hold of your wallet that had your little Post-it note in it, they go, I got all of his passwords.
Right.
But when they would try one, it wouldn't work, and they would have no idea why.
And there's a scheme I'm sure that you could come up with that you would somehow modify your consistent passphrase with something like the name of the site that would make it recoverable. That's what I use, Super Gen Pass for that, where I have a master pass, which it hashes in a one-way hash the master pass and the name of the site to create a unique password for the site. All I have to remember is a master pass.
And then you're always able to regenerate that from
I
that.
can regenerate that.
Yep.
But, ultimately, LastPass or KeyPass, if you like open source, is such a good solution because it creates strong passwords and memorizes them.
And when Thomas did this post back in August of 07, LastPass didn't exist. And frankly, LastPass has solved all of my online logon problems. There are some situations which are not online where you can't have access to LastPass, and that's where this conversation, I think, is worth applying.
Right. Is his math, though, is not wrong at any point here, is it? Or is there?
No, I think his math is right. He just makes some assumptions, and the comparative strength issues I take issue with because he says, as I indicated, all lowercase is less strong than uppercase, lowercase, numerals, and symbols, which really is not the case.
Got it. Very interesting stuff. I'm sure Thomas Bechtel would not disagree. He says the password he uses on his server is a 40-plus character, completely random passwords. He does not, and we should underscore this, use 3 words for offline sites. Always, if there is an opportunity for an attacker to at his leisure attack, this isn't going to work.
And the one thing I forgot to mention that I keep meaning to mention is that relative to brute force attacks, we talked last week when this came up about this notion of memory hard functions. I also wanted to mention that when we discussed WPA, the Wi-Fi technology, these guys, because they did it with really good crypto in mind, they take the phrase your login passphrase and they salt it with the access points SSID, which hopefully changes from one access point to another. That is, you did change your access points SSID and did not leave it left to Linksys or D-Link or Cisco or whatever. But then they hash it 4,096 times, not because doing it once isn't secure enough, but deliberately because they wanted to take a long time. So that it thwarts rainbow tables, both because it mixes the SSID as salt into the hashing function, but they do it 4,096 times so that there's a computational overhead for the actual production of the cryptographic key out the other end. And so that's one way of dealing with the offline attack problem, by just making it much, 4,096 times longer to get a key, which you would then test against the crypto algorithm in a Wi-Fi scenario. Yeah. So really, this is something that's been given a lot of time and attention because it's the way we authenticate, even today.
Slow the bad guys down.
Yep.
Steve, always fascinating. We have links to all of this information in the show notes. You have 16 kilobit versions of the show as well as the 64K full quality and transcriptions available at your site, grc.com. That's where you'll find Spinrite, the world's best hard drive maintenance and recovery utility, and lots of free utilities that Steve offers everybody for your security and convenience.
And something coming shortly called the Passcode Designer.
Oh. I like that.
That ties into all of this.
Yeah. So you'll find it grc.com. Steve is at SGGRC on Twitter. And next week we'll answer questions. So if you've got questions or comments or suggestions, and Thomas, if you want to respond, just go to grc.com/feedback, and the feedback form there will go straight to Steve's inbox, where he will comb through it. Steve, so nice to see you. Thank you so much. We do this show every Wednesday morning, 11 a.m. Pacific, 2 p.m. Eastern at live.twit.tv. I hope you'll join us for the live show. If not, you can always download it from Steve's site, our site, or anywhere finer podcasts are carried.
Thanks, Leo.
Thanks, Steve. We'll see you next week on Security Now.
Security Now.